Hello and welcome again as we look at yet another multiple choice question for IB Chemistry. This one following up very much on the last one that I shared, which you can access by clicking on the card above. But this particular question is asking which mixture of acid and alkali would produce a buffer solution. Buffer solutions are made by a mix of a weak acid and its salt. And to get that weak acid and its salt, it's very convenient to mix the weak acid with a strong base, or a weak base, strong acid. This particular question is about the weak base, strong acid combination. And that's why immediately you can eliminate both A and B as possible choices. And you can then narrow down your answer to C and D. And what you have to bear in mind is for a buffer to be successful, just as I shared in the last question where the buffering effect was coming from ethanoic acid and its salt, which was behaving as the conjugate base, where the ethanoic acid could have donated a proton and behaved as an acid, or the salt, the conjugate base, could have accepted a proton, and in that way pH would be controlled. In this particular case, what you need to have is, in your flask, you need to create a mixture of NH3, which is of course a weak base, and that needs to be in equilibrium with NH4 positive, its conjugate acid. And to create that effect, what you need is to have a reaction where not all of the aqueous ammonia is consumed, only some of it is consumed and some of it is converted to its salt. So what you would notice here in all of these is the molarities are all the same. There is a 1-to-1 ratio in the reaction between HCl and NaOH and HCl and NH3. So the mole ratio is irrelevant and the concentrations are irrelevant because they're all the same. So therefore, you're just looking now to see what mix of volumes would give you a mixture where you end up with some ammonia and some of its salt or its conjugate acid. And that would be answer C, where you start with 60 cm cube of 0.1 moles per dm cube ammonia, NH3, and that's reacted with 40 cm cube of 0.1 moles per dm cube HCl. And because you have the same molarities and because the mole ratio is 1:1, you can be confident that you're going to end up with an excess. You're going to end up with not all of this 60 cm cube reacting, only 40 of it reacting and some of it left over. And of course, some of it would be converted into NH4Cl, which could behave as a conjugate acid. This could become a proton donor as it sits in solution and it's able to donate a proton, and this NH3 could of course accept a proton. And this is the objective of a buffer, to have a system where regardless of whether you have an increase in acidity, a small increase in acidity, you need something to take away protons, or you have an increase in alkalinity where you need something to donate protons, and in so doing bring the pH back to the level that you want to keep it. That's the purpose of a buffer, to resist changes in pH. And to create that scenario where pH changes can be resisted, you need a mix in your flask of a weak base like ammonia and its conjugate acid. Or, like I shared in the last question, a weak acid like ethanoic acid and its conjugate base. Answer to this question, C.